Hello there, welcome to my presentation. I'm Dominik, I'm a Flutter GDE and I work at Very Good Ventures. And today we're going to talk about animations in Flutter and how to improve your animation skills. I hope that after this presentation you will leave with some more inspiration how to improve your animation workflow when doing Flutter applications. If you have any questions, feel free to drop me an email or find me on Twitter. And also, if you're interested, at VGV, we are hiring right now. So if you look for new opportunities, head over to Very Good Ventures/careers, where you can find more about all the positions that we have open. Let's jump in straight to the topic that we're going to discuss today. So, like most of you probably at some point tried doing some animations in Flutter, and there is like this popular notion that in Flutter animations are like one of the easiest and most convenient thing to do, and today I'd like to support this with some examples. So every application has some kind of animations, right? It's like a trivial sentence, but I just also want to the people like understand all the people that maybe don't have much experience with mobile, that animations are a vital part of the mobile application market right now. Every app that tries to conquer the market needs to have at least some degree of animation support, some micro interactions, some specific features that actually can drive the user engagement. And some of the most popular apps use it heavily. So in the center of the screen you can see Reflectly, one of the most popular Flutter applications, which like uses animations as one of the main features. It's like the driving force for this particular app. But many other applications also have this kind of notion that the animations are, for instance, gratification for the user engagement, or they make you feel more important as a user because some animation is like dedicated for you. So there's many ways to do it in Flutter, and today I'm gonna show you from like the basics up to some more complicated use cases how to make that happen. So again, over and over you will probably hear that there's like implicit and explicit animations, and frankly when you work with animations like on a daily basis, you rarely like think about like whether you want to use one or the other. I think it's more natural thing to do. Like sometimes it will feel more natural for you to just try out and make quote unquote implicit animation, and in other times you will just have to implement your animation controller and make it much more elaborate than with just a simple, I would say, widget. So implicit animations are like the go-to tool when you have to animate something simple, something quick, maybe as a result of some kind of state change. So for instance, on this slide, you can see the animated container. An animated container is like a generalized solution for the implicit animations. You can animate almost anything inside the animated container. Quick side note. Together with this presentation, I have prepared a simple application. This is also available as a Flutter web application. The link should be somewhere in the description and also at the end of the presentation. And in this application, we have several tabs, and each of them has some examples that will correspond to the slides that we have. So for instance, you have noticed that I had animation inside of my presentation, but if you want to try it out, you can just click here in the application. There's also source code available if you want to see how it's been done. At the beginning, everything will be almost trivial in the implementation. However, at the end, we'll have some more interesting cases. So just for those that may not be aware of like the basics of the implicit animation, right? Here we have the animated container. Whenever you click on that, some properties of that change. We have also some other animation, implicitly animated widgets. So for instance, here we have the animated opacity. So whenever you click on that, the opacity changes, right? From 1 to 0.3 and then to 0. And here we have also another interesting case of animated, implicitly animated widget, which is animated physical model. And this is, I would say, very interesting because this shows this aspect of Flutter that you can find widgets for almost any use case that you need. And animated physical model is one of the most, I would say, odd or like uncommon widgets that you will try to use, but at the same time, it's everywhere. And if you want to learn why, I recommend just head over to the documentation about the animated physical model. So we have a bunch of these implicitly animated widgets, and for most of the use cases, you should be able to use some of them in your app. Like animated padding will make the padding animated. Animated switcher will switch between two widgets that you provide, and we'll try to animate between them. So yeah, as I said, at the roszkowski.dev/animation, you will find the application as a Flutter web application, and you can just try it out for yourself. So how to use implicitly animated widgets in your code, right? The usage is like trivial, right? If anytime you have some animated widgets, it will start with the prefix animated, and it will mean that usually it's either implicitly animated, with some exceptions where it's not implicitly animated, but you have to provide some animation. But here we have animated align, and the only thing that you need to do is to change the property of this widget, in this case alignment, right? So here on the onPressed, I just set alignment to some random value. And also if we go back to our example application, if you click on that, you will see that it just changes the alignment smoothly between some predefined values. Really easy, nothing to be worried about or like concerned. However, sometimes you need to make something more custom, right? So let's say none of the provided by Flutter widgets can support your need, or you just feel like you use like 3 or 4 different implicitly animated widgets, and you maybe want to generalize or unify this somehow. And here where custom implicitly animated widget can come and help you. So in my case, I came up with an idea of having a loading indicator. So this loading indicator is just a typical circular progress indicator, but with a smooth transition between steps. This can be helpful, for instance, if you have a download indicator or upload or this kind of stuff, and you want to show to the user some kind of smooth indication of a progress. So in order to implement the smooth loading indicator, you will have to use the implicitly animated widget class. You can compare this to be almost the same as stateful widget in a structure, right? So implicitly animated widget has some description, similarly as to the stateful widget. Here you can provide any API that you want. I just provided progress, color, and background color. An important part is that you have to also have the implicitly animated widget state. Let me move myself to the right. Yeah. So implicitly animated widget state is something equivalent to the state in a stateful widget. So if we go further, you will see that the implicitly animated widget state just extends animated widget base state. And in this, you will have your build method, right? The one that will return the widget that you want to animate. So for instance, here we have the circular progress indicator, the thing that we've just seen in the animation. And it has some properties like background color, color, and value. Usually when you have a value, you provide something like 0, 1, 1.0, or you don't provide the value and then it just spins indefinitely. However, what we do here is that actually we call the evaluate on the tween that we have here. And where does this tween come from? And we're going to talk about tweens in the one of the next slides, because I know that for some of you at this moment, tweens can be a bit something new, right? So let's focus for now on this particular widget, and then we're gonna look into the tweens in particular. So the animated widget base states requires to override also another method called for each tween. So this widget will call this method for each frame, and what you have to do is that you have to call also function provided by this method, right? So here you will receive a function called visitor, and you have to call this with the parameters that you have access to. So the progress is the current value. So this, as you set state with your parent widget, let's say you will receive an information from your API client, HTTP client, that the progress is now not 0, 0, but 0, 1. Then this will be called because you called, for instance, set state, or maybe your change notifier was called with notify listeners. So this will be called, and the current value will be provided here. Then you have to provide the target value. So what I do is that I take this progress value that I just received from the parent, and I clump it just to be safe between 0, 0, 1 and 1, 0. We don't want to provide, for instance, 1.2, but it's just like redundant security. And then the third important part is this callback, where you have to provide a tween. And tween has this nice property that you don't always have to provide an end parameter to that. So this value that you will get here is the value of this will be called by the animated widget-based state between the previous and the current value. So for instance, between 0, 0 and 0, 1. And this tween will be used to interpolate the value of your animation. So in this case, it will be linear interpolation of a double. So the value that I have here will be interpreted as a double, and will be just frame by frame interpolated between 0, 0 and 0, 1. So let's see in practice how it looks like. So I also have this widget up here. So if I click, you see that it smoothly goes from previous value to the next one. As you can also see, I use it not only for the progress indicator, but also for the just textual representation of a percentage, right? So you can see that here the value changes immediately from 0 to 0.2, and this smoothly goes through that. So if you would like to see this, we can just go to the smooth. I need to find this, sorry. So implicit and implicit loader. So here, if you go to the GitHub repository, you will find a smooth loading indicator. There is a serial progress indicator, and also there is a counter. So smooth counter is also implicitly animated widget. And in this case, what I do is just for each tween, I just take my double value, and then I just put this double value inside of a text, right? And I format this to be in percentage. Nothing fancy, just a very simple usage of implicitly animated widget. And trust me, in many cases, using implicitly animated widget should be just fine. I saw my colleagues and other developers, after seeing this example, just trying out this implicitly animated widget with various different kinds of use cases. So just to recap, if you want to implement some kind of more uncommon implicit animation, you may be able to use implicitly animated widget. You can provide any type of value to that. It's all up to you, whether you provide a string, integer, double. If you can interpolate this value, you should be good to use it. And this is useful when you cannot find any suitable implicitly animated widget. Like I would say that the good thumb rule could be to just like, if you need to use more than 2 or 3 implicitly animated widgets to implement your feature, then maybe it's worth looking into the implicitly animated widget as a custom solution. Of course, the next level when doing animations is our explicit animations. And this means that in this case, you will have to drive the animation somehow on your own. Typically, you would use something like animation controller. And this animation controller is a class that hooks up to the Flutter engine and allows you to get some more, allows you to synchronize your animation with the Flutter frames. However, sometimes you may skip also the animation controller and use something different, and we're gonna look into that later. And when you have animation controller, you can create something like animation object, and then this animation object can be used for various widgets like scale transition, faded transition, or animated widget. And in my example app, you will find a bunch of different custom animations. I've been doing these and publishing them on CodePen, right? And here you can find some of them, and we're gonna look into some of them today. In particular, we're gonna look at this very simple animation that I have in the bottom left corner. But if you'd like to maybe learn how this kind of Flutter animated logo has been built, or like this animated Slack logo, the source code is all here, and you can just browse and see for yourself. So let's have a look at this particular guy. So in this case, we just have an icon button in this particular example, and we have a glowing border around it. Whenever you use animation controller, you have to instantiate this and provide something called vsync. And vsync is a way for the animation controller to know when each new frame gets rendered by Flutter engine. And you can get this from the ticker provider state mixin or single ticker provider state mixin. In order to engage or like start animation, you have to call forward on the animation controller. And in my case, I wanted this animation to repeat indefinitely and also with reverse. So you can also call repeat and reverse with true. You also need to remember about disposing the animation controller whenever your widget gets disposed. Then, if you want to use the animation controller, you would usually use something like animated builder. Animated builder can accept any listenable. So for instance, if you have even like your change notifier or block, you can use the same here as a dependency. In my case, I've implemented this, that I use a decorated box, and what I do here, and my child. The child will not be rebuilt with each frame. However, anything that's in the builder will be rebuilt with each new frame as the animation controller is moving forward. So in my case, I have my decorated box with some decoration, and here what I do is that actually I'm animating a padding of this container, right? So the padding changes from 8 to 0, because the animation controller will cycle the value from 0 to 1, each second. And here I just have my icon button. We can quickly go back here, and then, as you can see, this is how it works. You can also find this in my sample. So for instance, you can go here and you will find animated radiating icon and the same source code for you to browse. So you noticed that I've used animated builder, and animated builder is a very handy widget that you will most often use when working with animation controller. What it does, it accepts animation controller and listenable, and here the builder will be rebuilt anytime a new frame or a new tick is scheduled by the animation controller, and the animation controller will know this based off the widgets binding from Flutter engine. I mentioned tweens several times already, and I wanted to clarify more or less what are they. And I know that for many people at the beginning, tweens are not something intuitive, and I wanted to make it more intuitive for you guys because I know that it's very useful. So I found that tweens actually as a term appeared much earlier than programming languages even became a thing. So for instance, anytime you maybe when you watch like an old cartoon, like some Hanna-Barbera or some kind of Bugs Bunny or whatever, or Flintstones, you may notice that sometimes the characters in the animation appear to be like smudged, or like they are not super in focus, or however you would like to call it. And actually tweening or in-betweening was known in the animation industry many years ago. One of the biggest companies that used heavily used tweening also in computer animated graphics was Pixar. And in-betweening means that you give like the appearance of motion for an object. So you don't draw every frame, every movement of a character as a frame of the animation. You maybe draw the character a bit smooth, like with like no detail, just to show that, for instance, the hand is moving or the character is running. I highly recommend you to look into this article about tweens in the graphics animation, but I hope that this gives you like a nice hint of what a tween in Flutter actually is. So tweens are objects, classes that allow you to interpolate the motion, or in practice any kind of value that supports interpolation. So you can imagine a case where you have something that goes from 0 to 1 and want to map this to not be between 0 and 1, but maybe between 20 and 100. And tweens allow you to do so. So for instance, in the case here, and these two usages are exactly the same. Sorry about switching. And these two cases, something's wrong with my presentation. No. So these two code snippets are the same in the effect, i.e. they will give you the animation object. What's important, you can drive the controller with the tween, or you can animate the tween with the controller. So this is equivalent to each other. So for instance, maybe as you remember, controller will give you value between 0 and 1 by default, but you can map it onto some different scale. So for instance, in this case, what I want to do is that I want to map the value of 0 to the offset of 150 and value of 1 to offset 200 and 300. So it means that the object can be animated or like moved using this controller, but in a completely different scale than 0 and 1. And this is very handy. You can apply many different classes here. And then, for instance, if you have animated positioned or like just a positioned, you can just animate the position of a given object on a screen. And in my example app, I have prepared like an overview of how to use tweens. So for instance, if you go to this page, you will notice that there's a bunch of different behaviors or characteristics of a tween. So when you are using tween, by default, you will map linearly from one value to the other, right? So the value 0 will become 50 and value 1 will become 300. And in between of these values, the value will be linearly rising. However, sometimes you want to make it a bit more smooth, or maybe your movement shouldn't be like super exactly linear. You want this to be more natural, like physical, and this is where you can use curves and apply them to your tween. And in practice, every time you have any kind of interaction with the user, any kind of button, any kind of bottom sheet sliding up, this kind of stuff, you never want to have linear behavior. You always want to have a bit something that's eased or smoothened. So for instance, often you can use curve called ease that will just ease the movement all through the timeline, or you can also use something called let's say in this particular case easing out or decelerate. The decelerate is often used if you have something like iOS iOS-ish UI. This looks pretty good. Sometimes maybe you want to show like a winner badge to the user, then maybe bouncing or something like elastic could be pretty nice to use, because then just gives you this appearance of surprise. And how to use these curves with your tweens? It's also pretty easy, because when you have a tween, you can wrap a tween with another tween or something with a called curved animation. So curved animation is a class that will accept any curve that you like. So for instance, if you go to my presentation and find tweens, you will notice that I use a bunch of different curves, and I just apply them with my on my tween. So my tween is of offset between -2 and 2. So this is like what you can see here, from -2 to 2, and I just apply different curves onto this tween, just to show you that you can modify a tween just with a simple operation. Important part is that you can actually provide your own custom curve. So if you go to any of the curves that are defined, you will see that every curve just allows you to define some method, like for instance transform internal, and here the Flutter team just used something like bounce function. There is some maps involved, and you can of course create your own function. Let's say maybe you'd like to have a sinusoidal movement, or maybe something more complex, maybe something more custom just for your application. You can do this very easily. When you have tweens, you also have something called Tween Animation Builder. This is, I would say, a handy way to not worry about animation controller and still be able to use tweens. So on the right side, you can see that we have a Tween Animation Builder class widget, and we can provide a bunch of different properties, very similar to what you can provide to animation controller. However, in this case, you will not have to instantiate the animation controller, and the animation controller will be disposed by you. The difference is that you cannot customize the animation controller. So for instance, in this case, you will receive the you will have a builder and a child, same as with animated builder. In this case, you can just apply a tween. So what I do here is I just apply tween between 0 and 1, and also this accepts a scale, so I can override the scale, and whenever the scale changes, so whenever I rebuild this widget, this tween will also nicely animate. Let me show you what I mean. So here's my example application, and maybe you have noticed that when I open this, the text and the Flutter logo actually animated from 0 to 1. So let me go back again, and you can see. So this was the actual code that you have seen here, where Tween Animation Builder was animated between 0 and 1. And I can also change this value maybe to 10, and you can see that it changes to 10, and also I can change it to 30, and then to 1, and to 10, and then to 30, right? And the nice thing about Tween Animation Builder is that, for instance, if you need to continuously or like several times change your value, you can do this easily with the Tween Animation Builder, and it will remember the previous implementation. So this is the previous value. This is similar to what implicitly animated widget can do for you, but it also allows you to apply a custom curve, right? So this is handy, and you can also interpolate custom values. So you can sometimes choose between the implicitly animated widget custom or Flutter, the Tween Animation Builder. The next important thing with animations, and this is often visible in many applications, are staggered animations. And staggered animations are sometimes used, for instance, to indicate some entrance or to make some kind of more complex process a bit more acceptable for the user. So let's have a look at how we can do this. So here also in the example, you will see the staggered animation example. You can also like pause in the meantime. So let me play. Right, so we can see first the top thing comes, then the second row, and then the third row. So how you can do this? Let me show you. So there is like official guide how to do it, but I find that you can make it a little bit more friendly for yourself or also for your colleagues. So what I usually do in such cases, if I need to implement a staggered animation, is that I create my own builder, right? So this is, you remember, animated builder is just a widget in Flutter, and what you can do is you can also create your own animated builder, and this is this one I just called homepage animated builder. In this case, I'm just wrapping the animated builder, and I have my transition builder. My transition builder here is just typedef, and this typedef defines that it will accept a function that can return a widget, and this function will accept context, child, that will be not rebuilt, and something called home page enter animation. homepage enter animation will be my custom class. And this class, you can just think of it as a state class or a description class. And this class will have a bunch of different properties, which will be animations. And in the constructor of this class, I will just define some properties. So for instance, if I want to animate my header between header opacity between 0 and 1, and this is actually what is happening here. So if you go back to the application, you will notice that the header, when it comes, it's here at the top, sorry. The header, as it appears, it fades from 0 to 1. So what I do is that I apply something called curved animation. You remember this was with the we used this with twins to apply custom curve, and then our curve won't be any of the built-in Flutter curves. It will be our custom curve or like custom interval of a curve. So there's a class called interval, and you can apply a given fraction of a timeline to be used for this animation. What I mean is that here my interval is from 0 to 0.2, and I apply curve called ease in. What it means that the ease in function will be applied, and the movement will happen between 0 and 0.2 part of this animation. And then the other animation for the row 1 offset will be applied between 0.1 and 0.25, and then the other between 0.15 and 0.30. So let me show you what it means in practice. So here, whenever this animation appears, right, this was done in the first like 20% of the animation duration, then this was done in like another 20% of the animation, and then in another. This was overlapping as well, right? So it didn't happen one by one, it was actually overlapping one onto another. And what I really like about this solution is that if you have this two classes, the builder and the animation definition class called in my case homepage enter animation, you can call it whatever you want, then you can just use your homepage animate builder. You still need to provide the animation controller from somewhere, so I just pass it from upper widget, and here I have my homepage animated builder. And what I do here is that I just can access the animation properties in my builder. So here I just access animation that header opacity, that value. Then for the opacity and for the slide transition, I can just pass the animation. So I just pass animation that row 1 offset, and so on and so forth. And sometimes you can even get a specification for your animation in a way, in a form of a timeline. So for instance, in this case, you can have a text field opacity, then text field transition, button opacity, button transition, and then for instance button color. So you can have a really complex animation, but the moment you need to implement this, you will always break it down into smaller pieces of the animation, try to put them onto your timeline, and then this way you will be able to implement this just by using like a simple class for each of the properties that you want to animate. I really recommend trying this out. For instance, the same approach was used for the Flutter puzzle that we've built at VGV for Google, and you may look for the presentation by Bart, how they implemented the Flutter puzzle theme with custom animations. They used the same approach, and I think it was implemented pretty like robust, and you can just also learn a lot from this example. And sometimes you have to go on a lower level with your animations. So you may not use just the animation controller, but maybe something more powerful or more customizable. And what I usually do in such cases is that I use change notifier. So change notifier will just allow you to call function called notify listeners. So if you have any listeners for that, for instance, animated builder, you can trigger a new rebuild of this widget. And important part is that you want to synchronize this with the Flutter rendering new frames. So what you will do is that you will use the vsync, the same thing that you've passed to your animation controller before, but in this case you will just handle this manually. So what you can do is that when you receive a vsync, and vsync is just a ticker provider, so for instance single ticker provider mixin, you will create a ticker out of that, and this ticker will give you a method called onEachTick, and in this method onEachTick you will be notified how much time has passed since last frame, and you can do whatever you want with that, maybe do some calculations, await for some result, anything you need. And you also need to start this whenever you want to start the animation. So I have prepared, I would say, a bit more elaborate example here with Boyd's simulation. So the Boyd simulation is just simulating flock of birds, and in here you can just modify some properties of that. The birds can be a bit more willing to stay together, or maybe it can be faster, slower. You can also make their number a bit bigger, and the full source code is available, and you can just see how they operate. The funny thing is that at some point they just become like a one big blob, and I think they just went away. Yeah, not sure if they can come back. Yeah, so you can see they behave strangely if you put some different properties, but I hope that you can just see for yourself. Let me just reset them to be a bit more calm. And this was actually implemented with change notifier. Some maps is done in between. So for instance, if you need to calculate the position, you can do this on the side. Sometimes maybe you don't have enough time to calculate everything, so you can just optimize this and maybe just calculate roughly, right? Because you will know how much time has passed since last frame. And for instance, if you want to achieve 120 frames, so we can just assume that 1 second by 120 is 0.08 of a second, so 8 milliseconds per frame. It's not much, but you can, for instance, have some more like you can maybe divide the calculations between 2 frames, whatever you need, just to optimize for this time. So just to quickly recap, ticker provider is a thing that will let you know when a new frame gets built, and you can out of that you can create a ticker, and the ticker will have a callback, and this callback will be called every time a new frame is built, rendered by Flutter. Another very interesting thing in Flutter is physics simulation. So Flutter comes with several physics simulations. So for instance, you can have a spring simulation. This is used in some vanilla Flutter widgets, and how to use it is very simple. When you have a spring simulation, you just provide some properties, for instance, mass, stiffness, damping. If you ever studied some kind of engineering topics, you may recall the spring equation. These are actually the things that you provide here. And then when you have your simulation, it sounds very like cool, right? You have a simulation, then you use the animation controller with some high upper bound, because this animation won't last between 0 and 1. This can last much longer, and you rarely know how long it will take to finish the simulation. And then you can animate the controller, the simulation with your controller. And this is all that you need. You will receive some values, and you can use these values out of the controller to show something on the screen. So the controller's value will indicate the value of a simulation, right? So in this case, the spring simulation, I'm not sure if I can click on that to make it move. No. You can see how something would appear as a spring, but also we can do something more cool. Like in this case, you have the ball, and I implemented this with gravity simulation. So I can drop the ball, it will try to bounce, and this way you can have like a very basic gravity simulation. Again, the source code available in the repo. At the end of my presentation, I wanted to leave something about performance measurement. So we can have all the animations we want, but if they appear sluggish, janky, you will have a hard time convincing your client or maybe your users to like them, right? And there's a lot of possible optimizations that you can do, and this is a topic for another talk, maybe on like a real life in-person conference. So stay tuned for more information about this. However, the most basic thing that you can do to optimize or to see if there are any problems with your animation or with your performance of your app is to use performance overlay. This will render a timeline of how much time it takes to render something for your app. And of course, right now I'm running the debug mode, right? But if you would run profile mode, it would be even more interesting. So let's say performance overlay. So when you use VS Code, you can just call Flutter toggle performance overlay, and you will see this in your app. So if I go to my custom animation, you will see that, especially in debug mode, there is some junk, that not all the frames get rendered equally well. And it depends, of course. And the nice thing is that after time, Dart compiler is so smart that it will just optimize the code even in debug mode. But you can also run this in profile. This is really interesting. And another thing that I sometimes use is FPS widget. Here I have just some kind of basic implementation of that. There's many packages that allow you to do so. So for instance, here I can see how many frames I can see on my screen. So 60 frames easily, with some junk, of course, because of the debug mode. But it works pretty nicely even in debug mode with all these animations. If you happen to have any problems, then the Dart performance DevTools performance page can be handy. This is a beast. Let's recap what we have learned today. We have a myriad of implicitly animated widgets, and you can use them almost like any other widget in your app. However, if you need, don't hesitate to use animation controller. It's not bad to use. It's really handy sometimes and gives you a lot of possibilities. Sometimes you can use just Twin Animation Builder and you should be good. You don't even have to instantiate your own animation controller. Then, of course, there's a possibility if you need to create something like custom controller. And this would be, for instance, change notifier. And if you'd like, you can even use block or anything like that. Just use sticker provider. Then, if you need to do some kind of funny or even interesting simulations, you can try spring simulation, gravity simulation. If you want, you can just take the existing simulation and create your own. Maybe you like to make a bit more advanced gravity simulation that takes into account the aerodynamic drag, or something like this for your game. And of course, there is much more to learn. And like every month, possibly, a new animation related package or video is presented somewhere on YouTube or Twitter or Reddit. So definitely, if you want to learn animations in Flutter, there is a ton of knowledge. What I can recommend is that, for instance, I want to recommend you like the animations package, the Flutter Europe talk about animations, also the talk about performance measurement, and also when you're a developer, you sometimes forget, we sometimes miss the joy of building animations and all these like front-end related stuff, because there's like business stuff to be implemented, some API calls, maybe some hardware integrations. But frankly, for me personally, I find the most joy when building the app UI and animations. So if you can, maybe try to and do this kind of tasks from time to time, so that you can have some more experience and also more joy in your life. And this is what I really wish you for this year, and also for your work, so that you will be joyful and you will get as much satisfaction from your work as possible. My name is Dominik, and you can find me on Twitter, on my website, and also the source code for this presentation and slides is available on my GitHub. Thank you very much for watching, and I hope to see you soon, maybe in real life. Thanks a lot.